started out on the research rig, which is a small pilot scale.
Yeah.
And everything that ended up in the actual full-scale demonstration plant or the demonstration scale started out on that device right there, so that it's fully proven out. And that's the exact reason that we're building this, is to prove this out in Louisiana.
I completely understand it. And from your background, you can understand my next analogy, okay? If you're going to build an aircraft carrier, the fact that you know how to build a rowboat is not relevant.
Exactly.
Okay? The point here is that there are steps you have to take to commercialize any technology, okay? And these are the steps you have to take. I understand that. In fact, what you've done here is prove your point, that the pilot facility can become a demonstration facility, and increasing your probability that a full-scale facility will be effective. So, I'm going to bet you're going
in an industry like this,
Yeah,
you've got to build a robust commercial demonstration.
exactly. That's right.
You've got to do that. If you have the small lab talk university approach, you're not going to get to what you need to do. You know, there are things like preliminary process capability, which is a statistical analysis, ongoing continuous process capability. You can't measure those metrics and know that you'll get a reliable product for customers at the end of the day, unless you build something significant like this that you're looking at, that we're talking about here, and then transfer, copy and paste, and eliminate time, money, commissioning headaches. Make it happen quickly. And at the end of the day, Jack, as you know, you're not building for markets. You're building for customers. So you've got to be really flexible, and you've got to be nimble, and you've got to be able to turn like a speedboat. And that's why some of the 21st century ideas, which are along the lines of digital manufacturing, which you're seeing here today, flexible work cells, scalable modular approaches to increasing your CapEx and watching your revenue stream, watching your balance sheet, looking at profitability every step of the way as you serve those customers. And that's what plants like this do. This commercial demonstration needs to be this way in order to enter the market that the Chinese, quite frankly, have a 40-year head was turned on. So take it from there.
We started out with 1.8 tons of ionic clay and ran it. Then we separated it. Then we consolidated parts of it, ran it again, consolidated parts of it, ran it again. So we can reuse over and over until we get to the product that we're looking for. And what we have in the other facility is, the purpose of this facility is to demonstrate the technology of Rapid SX. But what we did at the other facility is we can make kilograms of oxides on a kilogram scale, so that we can take the chlorides, turn those into an oxalate, and then to turn the oxalate into an oxide. And so we established that in another part of the CDF. But the thousands and thousands of liters of chlorides is what you're looking at here. We've been operating this facility for over 2,600 hours in a semi-commercial continuous environment.
Okay. I don't think people realize how much material it takes to produce, for example, heavy rare earths. They never present in very high concentrations. So you need something of this magnitude to produce a commercially useful amount.
Yeah. The ionic clay that we started with had about 4% dysprosium and less than 1% terbium. And that's reflected in what you see here. So we have to get through a lot of chlorides in order to achieve just a small amount of this dysprosium samples.
Your positioning in Louisiana, in a whatever you want to call it, what's the exact term for
Trade zones.
Foreign trade zone, where taxes and tariffs are not assessed if the product is in and out in a certain period of time, okay, is an ideal location to process for the entire hemisphere, to be honest with you. This stuff is so valuable, you can fly it first class on a plane. It doesn't make any difference, okay? It's like gold, okay? So where you do it is not as important as actually doing it. And your location, Louisiana, perfect.
We have positioned ourselves to be able to build this plant with literally commercial off-the-shelf parts. When we constructed this plant, every once in a while we would need to run down to the Home Depot to get a particular element that we would need. We can get it there and finish whatever it is that we were doing. So very simple construction. Yes, there's a few components that are a little more sophisticated and customized, but in general, it's commercial off the shelf, and it's going to help us have a very low capex in the Louisiana facility and get to market extremely quickly.
Well, the most dramatic thing here is the reduced time in process.
Correct.
Okay.
Footprint.
Yeah, because your time reduction is an order of magnitude or two. Okay, therefore the cost is dramatically reduced, especially with conventional equipment.
Yeah, we think about everything in this process in dollars per hour per kilogram processed.
Right.
And obviously it's much improved. So, and then one other thing about the Louisiana plant is that yes, this height of this plant is going to be the exact same height as the Louisiana plant.
Okay.
And to the underside of these trusses that you see is like 15 feet 9 inches.
Yeah.
And we'll be able to process in Louisiana on a level 1 and a level 2, and then everything else will work around that mezzanine that we have to construct there. So we have a blank canvas in the Louisiana facility, and we built a chemical processing plant inside of a building here, and that's exactly what we're going to do in Louisiana.
So this is our human-machine interface. It's what talks to all of the panels that control RapidSX, where we get feedback from our sensors and pumps and other instruments. So here we can take a look at what's going on in the system, how it's performing, and we use this data to look at our KPIs. Up top, we've got what we call log trending, and this is a live feedback of whatever we want to look at in the system, whether it's the level of a phase separator or the pressure inside one of our columns or the flow rate of a pump. We've got access here through Historian to every single functional group that we run in RapidSX: extraction, scrub, stripping, wash. We can pull up different trends on the screen here, and we can overlay them together to make real-time assessments of how the system's performing. Right now, I've got a pressure transmitter and flow transmitter here, so we can simultaneously look at how pressure is influencing flow in one of our feed tanks.
You've obviously done a lot of data analysis, so you know where your limits are, right?
Yes.
Okay, so are they set here? So you get an alarm of some kind?
Yeah, and whenever there's an alarm in the system based off of lots of studies we've done to know the limitations of our equipment, well, we have different alarms that turn the system off, or alarms just let us know what's happening.
Okay.
Yeah. So
No, this station is monitoring this entire operation, yes?
yes.
We can operate the entire plant with one person.
Yeah, one single person can oversee everything from the feed area to the actual solvent extraction to where we store our chemicals in the back.
This is probably the most detailed explanation of any such system I've ever seen. Okay, no kidding. Okay, because SX is normally described as if it were some kind of magic.
Yeah.
Okay, because the public doesn't understand. Why? How could they? Okay, so what amazes me is how simple this system is. And
That was our philosophy with this plant is keep it as simple as possible.
well, and the result is necessity is the mother of invention. Okay, that's exactly what's going on here. You don't want to compete with contemporary technology, and so you've built this technology, which is better than existing technology, because it's cheaper. Okay, and so this
People are more efficient.
yeah, well, that's the point. And so this is how things advance in this world. And congratulations.
Thank you, Jack. Appreciate it.
Yeah.